Hello everyone, welcome to AI Anytime channel. In this video, we're going to look at Qwen2, which is a vision language model developed by Alibaba Cloud. It's a model, having multilingual capabilities mainly for Japanese and those languages. It has performed really well. It has, a state-of-the-art understanding of images of various resolutions and ratios. It has performed really well on the benchmarks when it comes to. So, how do we basically, evaluate these LLMs, guys, or the AI models? So LLMs, when it has large language model, only text. When you say vision language model, it has vision capabilities that can read your image files. So we basically benchmark those on different data sets like real world QA, doc VQA, math vista, so on and so forth. These are mainly for vision language model. Qwen2 can also understand videos, over 15 to 20 minutes duration. So now you can use this model for question answering, dialogues, content creations, and whatnot directly from video files. Now, you can also use this within AI agents. So agents can operate, like the mobile phone, robots, etc. And it has supports of languages like, Japanese, Korean, Arabic, Vietnamese, and different European languages. To use this model, I have to build the transformers from basically source, which is on GitHub. And let me do one thing, let me open, why not? Let me open Hugging Face. I'll just open Hugging Face here and let's search for Qwen. Yeah, you can see here Qwen2, and I'm just going to go inside any one of it. Okay, let's go to Qwen repository and you can see Qwen2. Let's click on Qwen2 and you can, it says, uh, we have Qwen, and right now this is not the vision one. Vision one is here. So when you click on Qwen2-VL, that's what it shows, vision language model. Now in the vision language model, the model has in two different variants. One is 2B and the 7B. Okay, these are the model that you can use. Both the models are equipped, but this is very fundamentals to understand that 7B will be superior than 2B, on different use cases. So that's what we're gonna try it out, guys, here, in this video. We're gonna look at how we can do that. So first thing that we're gonna do is prepare the model. Okay, so let me just bring up the Hugging Face thingy. So from transformers, I'm gonna import transformers provide Qwen modules, so you can use Qwen. It should suggest, it has Qwen2, and you can see it over here, Qwen2 for conditional generation. I'm gonna use auto tokenizer and auto processor. Okay, that's what I'm gonna use here. So auto processor, where it is? Here it is, and let's now run this. Next, let's get the model. So model, I'm gonna use Qwen2 and VL for conditional generation. And here I'm going to use dot from underscore pre-train, and within this pre-train I'm going to have my inference param. So of course I'm going to use Qwen. I'm not going to use Qwen-VL chat. I'll just bring it. I'll just bring up here. Okay. Now the model I'm going to use is 2B instruct. So let me just get the 2B instruct thingy. So if you look at here, 2B instruct, that's the model I need. I'll just copy this. It's not a gated repository, so you don't need to probably just like log in within your Hugging Face. You can just download the model weights. Qwen2-VL2B instruct. I'm gonna have a torch D type, for the data type tensor. Okay, so let me just get torch D type, and I'll keep that auto. And we don't need that for now. Okay, so let me just get rid of this. This is fine, this is fine, this is fine. Now processor, because we need the processor, so let me just define it. Auto processor from pre-trained dot underscore from pre-trained, and in this pre-trained I'm gonna just have here Qwen, the same thing. Let me just get this. Okay, copy, paste, and run. The model is around 4.5 GB in size, guys. Takes a bit of time, to do that. So let it happen. So what I'm gonna do is come down and keep writing the code. So I'm going to use Pillow to import local images in the notebook. So I'm going to have from import image, and I'm going to have import request module. So let me just get request and let me just run this. It will run up once the previous cell is completed. Meanwhile, we'll go next. So let's bring up an image. So I'm just going to have an image variable, and within this image variable, I'm going to have image.open, and in that, I'm going to basically bring up my image. So I'll decide which email to go with. Now you need a messages OpenAI compatibility, guys. So that's how you define if you use OpenAI, like GPT-4o models or any other models, right? So I'm going to do is the format is pretty similar. Now you have a messages. Now here you need a role and content. So let me just define a role. So this is how you go with that. So role and role of user, and then we need to define content, and again it's a list. So excuse me, in the content again it goes a dictionary, and here in content what we're going to have is type. So type is nothing but the image. You can also pass URL, guys, and if you want image, and then you need, I think this is good. So content type image, and then we need the text, right? What do you want to get out from this image? If you want to bring out, if you have any questions or you just want to use a specific task like OCR and whatnot, you can also do that. So let me just define in here. I think that is right. So we need the text, and then you can just define the text here. So let me just define the text, and I think we need to bring the image here. So we'll just bring up the image. So let's just go and bring up the image. So I'm just gonna use a random, image from, Google that I have downloaded, but you can use any other image. Okay. So let me just probably upload a couple of images here, guys. So I'm going to upload these images, okay, here. Now let's open that image. Okay, so let it happen. Probably you can also look at this. This is a Japanese. I want to test on different languages. Okay, so we'll see that. Let the image load. You can see the image has been like uploaded. So we have to load once the upload has been completed. We'll do that, guys. You can also perform OCR kind of task, guys. This is very good. This is one of the best model out there right now when it comes to, like when it comes to this size. So that's what I'm gonna do. So for now, let's do. Please extract the text or something. Please extract the text. And we have to test this out, right, in these kind of images if this works from the image or something like this. Okay, now I'm gonna pass the image, of course. So let me just run this messages. You have this message, and then you can define your text prompt. Okay, after that, so I'm gonna have a text prompt. Okay, text prompt, and then you apply a chat template. Okay, so processor dot apply chat template. Excuse me, apply chat template, and then you give the messages, and you add a generation prompt which is true. So let me just see if that is true. Yeah, that is fine. So we have that. Now text prompt is good. Now I'm gonna have my inputs variable here. So inputs, and then pass the processor. Let me just scroll it a bit down here so you can see it. Processor, and within this processor I'm gonna pass my text within a text prompt within a list. So let's just go text prompt. It's suggesting me text prompt, and then goes image, and you can do padding true, and you can just return the tensor, which is a PyTorch tensor. Now once you have the input, you need the IDs, and that you have to offload on CUDA device. So inputs equal inputs to, how do we do that? Okay, to model or device. You can directly write CUDA because I'm using A100 GPU, so you can do inputs to CUDA, and now you get the output. So let me just do output IDs, and after that you have to decode that. So output IDs, and then you have to do model.generate, and in this generate I'm going to pass my inputs, and you can have a max new tokens. So for now, I'm gonna give, this is too less. I want to give like 1024 as max new tokens. Oh, it has generated everything. Okay, max new tokens. Now I need the generated text. Okay, or generated text. Yeah, let's just do a. We have to then do a batch decode. So generated text. So what I'm gonna do now is in generated text, I'm gonna have these output IDs that we have in output IDs and length of input IDs. Output IDs, and then you're gonna do a for loop, which is right. So for input IDs, and then zip it together, input IDs and output IDs. So input IDs. Yes, that's right. That should be input IDs. And then we have output IDs. Okay. And then now we get the output text from it and use processor dot. This will not be text. Let's call it IDs, generated IDs. And then I'm going to do is processor dot input IDs. I think will be good. Okay. Input IDs. Yeah. Now processor dot batch decode. And in this, I'm going to pass generated IDs and skip spatial tokens true, and then clean up tokenization space equals true as well. So let me just come here. No, this, let's clean up tokenization space equals true. And then you can just do print output text. We'll just print to the next line. Okay, guys, let's run this now and see what we get. Let me just have a quick look from top what we have been doing. So what we did, we had a text prompt where we applied a chat template, and then we have inputs, processor, text prompt, images, image, padding true, and images we have to pass the images. Excuse me, we forgot to pass it. Okay, I'm gonna rename this. Okay, so let me just rename like sample or something, and then I'm gonna pass sample.jpg. Excuse me, and now I think this is good. Now this is fine. Text prompt, and then we have image, and then padding true, return tensor pt, and then we have inputs to CUDA. This is also good. Output ID is model.generate and passing the, you can give like any max new tokens, and then I've generated IDs passing the output IDs, length of input IDs, and then for input IDs we zip it together. Something I'm making a mistake. I'm just thinking because this is not making sense. It should not be, we have to zip input. Okay, that should be input dot input IDs. Now this makes sense. And then we zip it together. And then in output text, we have processor.batch decode, generated ID, skip special tokens, and clean up tokenization true. Okay, let's run this guy and see what happens. Okay, now what I'm going to do is I'm going to do print output text. And when you do print output text, it gives you, it didn't give you anything, the text. So let me just open this image here. And okay, I'm gonna say explain the image. Probably not able to read the handwritten or scanned notes. Let me see if I say explain the image. and we'll see if it's able to explain. It's not able to extract from a scanned handwritten very old image sample that we have in a Japanese language, so it didn't work for that image. Now let me see what happens here when we do that. Okay, now it explains but not able to extract. It says the image is a Japanese invoice document. Here the detailed description of its content. Okay, now it has given you the content over here. So it has given, I don't know why when we say please extract the text, it didn't extracted the text. Okay, probably not a good prompt. It gives you, yeah, it gives you the numbers in the 2B model, which is fantastic. Very small model in size. Place of origin, Japan. The recipient, you can see Taro Japan. But what I want to see is that everything that it has generated is in English. Okay, so it's not only looking at the English, not looking at the Japanese thingy that you have. So basically, it gets you. Okay, that is fine. Now what I'm going to do next is we have this image, of sample. So I'm gonna, you know, basically rename this file. So let's rename and call it. What should we call it? Let's call it to item.jpg, and I'm gonna copy this here. Let me just copy, open a Word file, and in this Word file, I'm going to save this for later benchmarking. So you can see I've saved it, and now next is I'm going to change the image. I like the answer. It's fantastic. Okay, now let me just, because looking at the size of the model, which is to be instruct, like it's an instruction model. Let me explain the image, or uh, okay, let's first explain the image. Okay. Mm, mm, the image is a business proposal template from, uh, excuse me. Okay, did I close that? Yeah, we can open it. You can see this is state is small business. It's like looks like a proposal. Yes, it's like a quote mainly. Business proposal template from Tate Small Business located in Los Angeles, California. The template includes various sections such as the sender and recipient information, project details, and a note from sender. Here the detailed breakdown, blah blah blah. It gives you a detailed breakdown. Looks like, yeah, looks like good. Okay, what I'm gonna do now? I'm gonna ask some questions. What is the unit cost for website design? Let me ask. Okay, let me first copy this thingy as well. So I'm just going to copy this thingy here and then paste, below. Now what I'm going to do, I'm going to ask some questions, a visual question answering, and let's see if this is able to make any sense. What is the unit cost? So let me ask this question. What is the unit cost for, what can we ask? Unit cost for the website design. Cost for the website design. And let's do print output text. The unit cost for the, let me see if that is right. Fantastic. That's really, that's a great answer, guys. So what I'm gonna do now, let's probably ask a combination here. Let's see if we can combine. Okay, let me ask this. Okay, so I'll just also copy this here. Uh, okay, we can take Arabic as well, guys. Just to test it out if it's able to answer any Arabic thingy. So what I'm gonna do next is scroll a bit up. Which two, which two, uh, which items are the costliest one? Are the costliest in the list? Something like this. Okay. Let's see if it's able to. I'm just testing a bit of on the reasoning side. I'm trying to see if it can. The two costliest items in the list are brand logo and website maintenance. Oh, okay, fantastic. That's right. But maybe you need a bit more complex thingy here, guys, to test it out. Okay, let me just paste this. I'll make this a bit So you can get it in a single line here. Okay, next question here. So let me just test it out. Uh, and I'll just get rid of this here. Something else. Can we try something else? Different types of use case. Let me try some different types of use case. What can we ask? What can we ask here, guys? What do you guys think? Ah, okay. I'm gonna ask faulty motherboard. Let's take an image of a faulty motherboard. So I can take probably these are the leaking capacitors that we can see here. Yeah, we can take this. Let's take this image. Okay, I want to save this image here. You can also download this in Colab directly. I'm gonna save this here. So let me just save it and bring it up here. And I'm going to upload this image and we're gonna trying to see if we can use this model for like in manufacturing industry or servicing industry as whatnot. So I'm gonna do is again a demo or something, and I want to change this here. So let's just do demo.jpg. Oh, excuse me, I just ran it again. Like which two items are the costliest? It will hallucinate. So I'm gonna do is uh, what's wrong in the image? Can you explain? And now let's try it out if it's able to infer anything out of that image, because that's quite important, guys, to solve complex use cases with these LLMs and not only building general chatbots every day. So let's see if it's able to, because the invoices, I was like pretty convinced that it has some capabilities. It says, oh, okay, it gets the motherboard. That's I really liked it. It says the image shows a close-up of a computer motherboard with several capacitors and other electronic components. The capacitors appear to be dirty or covered in dust, and you can look at here. It says which can indicate that they have been exposed to moisture, because that's right, it's leaking capacitors. This can lead to degradation of capacitors performance and potentially can damage to the motherboard or other components connected to it. Here are some potential issues that could arise from the situations, blah blah blah, and it goes in and talks about it over the time, the builder of that, blah blah blah. Okay, fantastic. Alibaba Cloud has done an amazing job, guys, with this fantastic model. I vouch for this model. I really loved it. Now let's try it out something else. So what I'm gonna do is, uh, how can we take something else? Let's try out one more use case, guys. Which use case you guys want to? Okay, uh, United Tactics against Liverpool. Can I get some image? Is there any image available? No, I had an image that I wanted to try. Okay, let me see. Dalot and Mazraoui up in field against Liverpool. Exposed tactics. Yes, I think this image makes sense. If not, yeah, let me just download this image. Okay, it's a WebP file. Okay, I'm gonna convert a WebP to JPG. You can also change extension and get it done, but sometimes if the file is corrupted or something, it doesn't work. So better to always convert. I want to see if it can help in finding out what's wrong, in the images. Okay, so let me just come here and upload this file. Okay, chances against Liverpool. I just want to see. Yeah, is this the image? Uh, no, that's fine. Probably why not? I need a clear image, because you cannot give a bad image and expect to. I'll just disagree here. Okay, uh, and you can see how bad they have been playing. Okay, anyway, this is an old image. I'm gonna upload the image here and I'm going to rename this. Okay, we already have uploaded, I guess. That's fine. Let's rename this, and I'm going to rename and name it like pool.jpg. What's wrong? I'm gonna say, what is wrong with this, with the tactics in the image? It is a football match against, something like that. Okay. Your analysis should help the coach. And let me just go up here. Okay, let me just first come down. And what I'm going to do is go up, and in the demo JPG, I'm going to call it pooled JPG. Now let's run this, guys. This is going to be our last inference, with this image. You can also fine tune it, why not? I can create a video. Like I've created a lot of videos on vision language model fine tuning, like IMP-v3, Edifix 9B, Florence 2, and whatnot. So we can also fine tune Qwen2-VL. And now let's print the output text here and see what happens. It says the image shows a soccer match with a red circle highlighting a specific area. Oh, okay, it gets that as well. And the red circle appears to be placed over a player who seems to be in a vulnerable position, possibly due to being too far from the ball or being cut out of position for the play. Here's an analysis of the potential issues with the tactics. Positioning: the player in the red circle is positioned too far from the ball, is not a good position to receive the pass or make a play. This can lead to poor team cohesion and a lack of support for the player. Okay, I will use this for later analysis. So I'm just gonna copy it here. Okay. Cool, guys. So fantastic. One of the best model I've tried so far, to be honest, when it comes to optical character recognitions, doing, performing visual question answering on top of images and whatnot. I really liked it. Okay. There are a lot of use cases that you can solve with this image. Let me know if you have any question, thoughts. I'll give this notebook in the comment box. You can find it on GitHub as well. And you can read more about Qwen2 here, of course, on Hugging Face. If you have any question, thoughts, or feedbacks, let me know in the comment box. You can reach out to me through my social media channels. Find those information on channel banner and channel about us. If you like the content, please hit the like icon. If you haven't subscribed to the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. That's all for this video. Thank you so much for watching. See you in the next one.